Cisco Center of Excellence at NHC, course Routing and Switching 1, course code NHOP09. So today's session is based on hands-on session using Packet Tracer to configure static routes. So we will be taking this particular topology for configuring static routes. In this topology you can see that you have a router 0 which is connected to 192.168.1.0 network. This is 1.0 network. This is 2.0 network, 192.168.2.0 network. Router 1 is connected to 172.16.1.0 network. Similarly, it is connected to 192.168.3.0 network, and it is connected to 172.16.2.0 network. There is another router 2 which is connected to 10.100.200.0 network. This is 10.100.200, and it is also connected to 172.16.2.0 network. So some of the networks are directly connected and some of the networks are remote networks. We have to understand these two terms. Directly connected networks for router 0 are, look at here, it has three different interfaces. One router interface is gigabit ethernet 0/0, another gigabit ethernet 0/1 connected to this interface, 1.0 network connected to this interface, 2.0 network connected to this interface, and one 3.0 network connected to serial interface. These are directly connected networks to router 0. Now if we see router 1, the directly connected networks are 172.16.1.0, 172.16.2.0, 192.168.3.0. These three are directly connected networks. It has three interfaces. These three interfaces are connected to these three networks. Similarly, router 2 is connected to two directly connected networks. This interface is connected to 10.100 network, and this interface is connected to 172.16.2.0 network. So these are directly connected networks. Which are not directly connected to that router will be the remote networks for those routers. Now for this router 0, which all are remote networks? This network 172.16.1.0 is a remote network. These three are directly connected. Now all other are remote network. For router 0, 172.16.1.0 is remote network, 172.16.2.0 is remote network, 10.100.200.0 is remote network. So we have to write IP route command for remote networks. Means we have to add static routes manually for remote networks, and directly connected networks will be connected on its own by assigning the IP address. So when you assign the IP address, these directly connected networks will be connected automatically, but you have to manually assign. Static routes means manually assigning the routes. You have to manually assign the routes for remote networks. Now first we have to understand what is remote network and for which all networks we have to manually configure the routes. For router 1, if we see, these three are directly connected networks, and for router 1, 192.168.1.1 is remote network, 192.168.2.0 is remote network, 10.100.200.0 is also remote network. So we have to add these route to this network, 192.168.1.0, 2.0 and 10.100.200.0. For these networks we have to manually add the routes. Now come to router 2. Again we will see here these two are directly connected, rest all networks are remote networks, and we have to manually add the routes for all remote networks. Remote networks for router 0 are 192.168.1.0, 192.168.2.0, 192.168.3.0 and 172.16.1.0. All these are remote networks. Only these two are directly connected networks. Directly connected networks it will take once you assign the IP addresses. So first in the topology you have to make out which all are the directly connected networks and which all are the remote networks. And whatever are the directly connected networks, once you assign the IP addresses to all the devices in the network, those directly connected networks will already be taken, and for remote networks you have to manually assign the routes. Now let us look at how to create this topology and what all commands we have to use to manually assign the routes. So these are the objectives of today's lab. Configure all PCs and switches with given IPv4 addresses. Configure router 0, router 1, router 2 with given IPv4 addresses. And then we have to configure all the serial interfaces of router 0, 1, 2 with IPv4 addresses. And then configure static routes at router 0, 1 and 2. And then we have to verify end-to-end connectivity. We will see all these objectives one by one. Now first we should know about serial interface. Two routers must be connected through serial high-speed WAN interface cards. So whenever we have two routers, in between two routers you have to make a serial connection. These are nothing but WAN connections. These interface cards are inactive by default and we have to activate them using certain steps. We'll be seeing what are these steps. Just I'm telling you what are the steps, and then we will see it in packet tracer. You have to click on the router 2, the router 0 or any router, and then go to physical and then HWIC2T. This particular interface card we are going to use is nothing but WAN interface card, and then we have to power off the router and drag and drop the serial interfaces in empty spaces and power on the router. So these serial interfaces we have to activate them using these steps. We will see how to do this procedure we will learn. So you can see here, if you go to router 0 HWIC2T, you have to select that. This card will appear here. This card should be placed in these empty spaces. So before placing it in empty spaces, you have to power off. This button will be on. It will be showing little green color light. So you have to click on this button to switch it off, and then drag these interfaces here in empty slots, both the empty slots, and then power it on. Again click on this, it will power it on. This is how we will add the serial interfaces. Once you add the serial interfaces, then you have to assign the IP addresses to all the interfaces, whether it is gigabit Ethernet or whether it is serial interface. The commands are similar as we have seen in previous lab. Interface G0/0 and then IP address related to that network, and then subnet mask and no shutdown to activate that. Similarly, we have to assign IP address to gigabit Ethernet 0/1 interface, and then we have to assign the IP address to all the serial interfaces. Interface serial 0/0/0 and then IP address of that interface, subnet mask, and then no shutdown to activate that. Similar procedure we have to do at router 1 and router 2 also. After assigning these IP addresses, your directly connected networks will be up. So we can send our packets from one network to all the directly connected networks. Now if you have to connect the remote networks also, we have to manually assign the static routes. Now for router 0, as I already told you, these are all directly connected networks for router 0. We have to add one route for this network. This is remote network. We have to add one route for this network also, because this is remote network. So we have to write IP route command, IP route, and our network is 172.16.1.0 for this first remote network, and then subnet mask, and then we have to choose the exit interface. Exit interface will be this particular serial interface. Okay, for router 0, this is the interface it will be leaving from this router to move to another network. So this is your exit interface. So we will be writing exit interface. Similarly, one route we have to add for 10.100 network. So IP route 10.100.200.0. Again subnet mask, and the exit interface from router 0 will be this. Similarly, at router 1, again we have to write the commands for 3 different networks. You can see here for router 1, these three are directly connected networks. This is remote network, this is also remote network, and this is also remote network from router 1. So one IP route command you have to write for this 192.168.1.0 network, one IP route command for 2.0 network, and one IP route command for 10.100.200.0 network. Fine. Now from when we have to choose the exit interface from router 1 for 192.168.1.0 and 2.0 network, the exit interface will be this serial interface, whether it is S000 or 001, 010 or 011, whatever you have chosen. This exit interface you have to choose for these two networks. And for this network, this is the exit interface, this serial interface IP address of this is the exit interface for 10.100 network. So we have to choose the remote networks for this. 3 IP route commands we have to assign for router 1. Similarly, if we look at router 2, these two are directly connected, and one route you have to add for 1.0 network, 192.2.0 network, and 172.16.1.0 network. 3 IP route commands we have to use, and serial interface, exit interface will always be this one, S000 or whatever we have chosen here. We have 4 options, whichever is available we can choose. So whatever you choose, for example, if I have chosen S000, so I will be writing exit interface for all these 3 networks will be S000, because from this network 10.100.200, if any packet comes, it will leave this interface only. This is the exit interface, whether it has to go to 172 network, whether the packet has to reach to 192.168 2.0 network, or whether the packet has to reach to 192.168 1.0 network. We should always remember that default gateways are very, very important on the PCs. We should not forget that, otherwise we will not be able to ping. So now let us see how to do it on the packet tracer. So we will open the packet tracer now, and we will do this activity. Go to the front one, and wherever we have the topology, that topology we will keep in our mind, and now we will write all the commands in packet tracer. Open the packet tracer. We have to take 4 pieces, so we will take 4 pieces, and after 4 pieces we need 4 switches. 4 switches are required. 4 switches we will take, and then we need 3 routers. So 4 switches we have taken. 1 switch number 2, 2960 series we have to take. So once you take all the switches, then we have to go to the routers. So you have to choose 1941 series router, 1941 series, 1941 series, and then again 1941 series. Now we have to do the connections. So as I already told you, copper straight through cable between PC and the switch, and again copper straight through cable between the PC and the switch, and again we have copper straight through cable between the PC and the switch, and again the copper straight through cable, fast Ethernet here, and any port which is available, fast Ethernet here. Now we have to connect this switch to the router, gigabit Ethernet interface on the other side, router side. So I have selected G0/0 here. Again I am selecting here any fast Ethernet port and gigabit Ethernet G0/1 here. Now here also we can select this switch and any fast Ethernet port here, and gigabit Ethernet G0/0 I have selected here, and again this switch, fast Ethernet port, and a gigabit Ethernet port here, gigabit Ethernet G0/0 interface. Now in between two routers we have to take the serial interfaces. For that what we have to do is go to the router. We'll do that procedure now. Go to the router, click on HWIC2T, and this is a power button. You have to switch off the power, drag these two, drag this interface in these two empty slots, and then again switch on the power, right? So we have enabled serial interfaces on that, and now again we will do the same procedure here. Switch off this and then drag this to empty spaces and then power it on. Again same procedure on router 2 also. We will click on this and we will go to HWIC2T, switch off this. After that, drag these interfaces into the empty space and then power it on. Now these are the serial interfaces. We can choose these serial interfaces and then we can connect between these routers. So we have S010, 4 different ports are there, 011, 000, 001. So I'll be selecting 000 this side and I have selected 000 on the other side also. Again I will take this serial interface and I will connect 001 on one side and 000, whichever is empty, anyone you can select. So I have selected 000 on the other side, 001 on this side. You can place your cursor here and you can see what serial interface you have chosen. Okay, so now I have done the connectivity. Now I have to go to these PCs and I have to assign the IP addresses to PCs, and then I have to assign the IP addresses to all these router interfaces. Once I assign the IP addresses to all these router interfaces, then my directly connected networks will be all up. Okay, so that connectivity will be there between directly connected networks. Now if you see this network is 192.168.1.0. So I'll go to this PC and go to desktop IP configuration. This is 192.168.1.2 and I can give 255, 255, 255.0. I'll just see here what IP address is assigned. Instead of 1.2, let us assign 1.10 only. Whatever is given in the topology, you can assign 1.2 also because it is in the range of the network. Okay, and we will be assigning this will be the default gateway, and for this the IP address is 192.168.1.1. the default gateway also we have given for PC0. Now go to PC1 and go to desktop IP configuration. Now this one is 192.168.2.10 and 255, 255, 255.0, and my default gateway will be 192.168.2.1. So I have assigned IP address to this PC also. Now I'll go to the third one, desktop IP configuration, and for this my IP address is 170.16.1.10 is the IP address, and 255, 255, 255.0 is the subnet mask, and then my default gateway will be 172.16.1.1. Okay, so I have assigned here also. Now for PC3, again I'll go to desktop and I will assign the IP address and the default gateway here also. So my IP address is 10.100.200.10 is the IP address. 255, 255, 255.0 is the subnet mask, and then I am choosing 10.100.200.1 as the default gateway. This IP address will be the default gateway. Okay, so once you have assigned the IP addresses, now we have to we have to assign the IP addresses to each and every interface of the router. Okay, so what we will do here is we will go to this router. This router has 3 different interfaces. So I'll go to CLI and I'll go to I have to write here no, and then enable configuration terminal. I'll move to global configuration mode, and here I will write interface G0/0 is my first interface, which is connected to 192.168.1.0. so G0/0, and then I will write IP address 192.168.1.1. 1, 255, 255, 255.0 is the subnet mask. 1.1 is the IP address of that, and then no shutdown. So my first interface I have given the IP address. Second interface I'll again go G0/1 and then IP address, then 192.168.2.1, then 255, 255, 255.0, and then no shutdown. Okay, so again I have a serial interface. Serial interface on this is S0/0/0, and then I have IP address given to that as 192.168, 192.168.3.2, 3.2, 255, 255, 255.0, and then no shutdown. Okay, so I have assigned the serial interface also, and these are the three interfaces, directly connected interfaces. I have assigned the IP address to all. Okay, now I have to go to router 1, and here again I have to assign the IP addresses. Here type no, and after that enable configuration terminal. I have to go to int G0/0 first, and for that my IP address is 172.16.1.1, 255, 255, 255.0, and then no shutdown. You can see here this is our interface G0/0. This one G0/0. For that we have assigned the IP address. For this IP address according to the topology is 172.16.1.1. Same thing we have assigned to G0/0 interface. Okay, so 1.1 we have assigned. Now our next thing is we have two serial interfaces here. My left hand side serial interface is S000 and my right side interface is S001. So S000 is belonging to 192 network and S001 is belonging to 172 network. Okay, so we will again assign the IP addresses to both these interfaces. You have to exit from here, go to global configuration mode, and then assign int JS 0/0/0. My 0/0/0 is on the left hand side. I'll recheck again. It is on 0 left hand side, and so I have to assign the IP address. IP address 192.168.3.3 is the 192.168.3.3 and 255, 255, 255.0, and then no shutdown. Okay, so after this I have to assign one more IP address in this int serial interface int s 0/0/1, and in that IP address is 172.16.2.2, 255, 255, 255.0, and then no shutdown. Okay, so these serial interfaces are assigned the IP addresses. All the two interfaces I have assigned the IP addresses. This is S001. Right, see these all are turning green wherever we are assigning the IP addresses. They are turning green now because these are directly connected networks. Okay, so now coming to the third one, here we have two interfaces we have, and we have to assign the IP addresses to both. Again we will go here, enable configuration terminal. So here if we see in router 2, again we have to assign the IP addresses. One is my gigabit ethernet 0/0 interface. This is my gigabit ethernet. I'll show you here. G0/0 is popping here. Once you place your cursor here, G0/0. Now this G0/0, the IP address is 10.100.200. Please correct it. This is 10.100.200. The network will be same. 24 bits. First 3 octets will be same for all these 3 devices in this network. 10.100.200. So we will assign the IP address to G0/0. In G0/0, then IP address and 10.100.200.1 and 255.255.255.0, and then no shutdown. No shutdown for this. We have assigned the IP address to this gigabit Ethernet interface, and then we have another serial interface. My serial interface is 000, and then IP address, I have to assign the IP address to this. This is the IP address 172.2.3, then 255.255.255.0 is the subnet mask, and then no shutdown. Okay, so my all the interfaces I have assigned the IP addresses. You can check here, all the interfaces are assigned the IP addresses. This has turned to green now. Now what I have to do is I have to assign the routes for remote networks. Now if I see router 0, this is my remote network and this is also my remote network. So I have to assign a route for these. So for that, again you have to go to CLI mode. You have to go to the global configuration mode and write the command IP route and the network address. For this the network is 172.168.1.0, and then 255.255.255.0. You have to remember that this is the network address which you have to give. You are not going to give the IP route command for each and every device on the network. You will not write one route command for this PC, one route command for another PC on this network, not like that. You have to give the network address here. 1.0 will be the network address. Okay, so one route for this network, and after that to a particular destination, to a particular PC, switch will send the data. So 172.16.1.0 and then subnet mask, and then we have to give the interface. Exit interface from this router is this interface S000. Any packet from this PC, it will leave S000 to move to this. Any packet from PC1 also will leave through this interface. This is the exit interface S000. So again we have to give here the exit interface S0/0/0. It will show you default route without gateway. This is nothing but a warning which can be avoided. Okay, so our route is added for this. Again I have to go to IP route, and then now I have to add 10.100.200.0 network. We have to remember network address should be given here. Then 255.255.255.0. Again my exit interface for this will be S0/0/0. Okay, so I have added both the routes here. You can check. See if my packet from these two networks has to go to this network 172 network or 10.200, it has to leave through this interface. So this is the exit interface for both the cases S000. Okay, now we can check whether our routes are added or not by using the command show IP route. Show commands are used at privileged mode, so you have to exit and move to privileged mode. Here you can type show IP route. So you can see that C and L, these are directly connected routes, directly connected networks, and SS, these are nothing but static routes which we have added. One route we have added to 172.16.1.0 network through this serial interface 0/0/0, and one route we have added to 10.100.200 network through this serial interface S0/0/0. Right, similar procedure we have to do at router 1 as well as router 2. At router 1, now I have to add one route, IP route for 10.100.200.0 network. The subnet mask is 255.255.255.0, and my exit interface from router 1 to go to this is this serial interface S001. To move to 10.100.200 network from router 1 the packet has to leave this interface. This is the exit interface S001. So I have to type here S0/0/1 S001. Okay, now similarly I have to use another IP route command for 192.168.1.0 network. 255.255.255.0 is the subnet mask, and my exit interface is S000. Okay, so this is my 1.0 network, 192.168.1.0 network, 1.0 network, and from router 1, if it has to leave, any packet has to go to this destination, then it has to leave this interface. This is the exit interface. Any packet which has to move from PC2, it will leave this interface, exit interface, and move to these two networks. So exit interface will be S000. Okay, similarly I have to add one route, IP route 192.168.2.0 network, then 255.255.255.0, and then S0/0/0. So I have added all the three routes to this network, and this network from router 1. Now if we go to again router 2, we have to add three different networks. Okay, so three route commands. Again we will go to global configuration mode, and we will add 192.168.1.0 network, 255.255.255.0, and S0/0/0. If we look at here, this interface is S000. So if this is the source, from here any packet comes, this is the exit interface. Exit interface for this network, this remote network, and 192.168.1.0 network. All the three networks, the exit interface will be this. This exit interface is S000. So now I'll be writing all the IP route commands. IP route 192.168.2.0. Again it will leave from this, and I have one more last command which is for 172 network, 172.16.1.0 network. So I have same S000 as the exit interface. I have added all the routes. I can check whether three routes are added or not. So show IP route is the command. So I can see here one static route is for 1.0 network, another static route added is for 2.0 network, and third static route is added for 1.0. For all that, the serial interface is 000. So our routes are added perfectly fine. Now we have to verify whether pinging is happening or not, whether we are able to send our packets from one network to another or not using static routing. So what we will do is we will take this PDU, packet data unit, and we will send it to PC1. So first packet may fail because of the delay. You have to check it once again. If you do, it is successful from PC0 to PC1. Again you have to check from PC0 to another network which is PC2. First time it may fail, it is failing PC0 to PC2. You have to check it once again, go to PC0 and PC2, and now it is successful. It is successfully working because all the routes are added, and if your IP addresses, your routes are correct, then you will be able to ping from one PC to another. Again we can check the third connection to third network also. First time it may fail because of the delay, and second time we should be able to ping if everything is connected. So here again it is successful from PC0 to PC3. So in this hands-on session we have learned about how to configure the static routes. For configuring static routes, you have to first see which all are the directly connected networks and which all are the remote networks. Directly connected networks will be connected on its own when you assign the IP addresses, and for the remote networks you have to assign different IP route commands. Okay, and we have to always remember that default gateway is very important. At PCs we have to give the default gateways whenever you are using the routers. Thank you.